So as you have said, this is normal probability distribution and is the most used because it is simple and is applicable in almost every circumstance. It requires that the mean should be 0 and the standard deviation should be equal to 1. But in the event that these two characters are not satisfied, then we use a formula we call Z, a standardization formula, which we already have written, and we shall be writing it almost everywhere to compute the probabilities. Now, once you have the value of Z, it is the one that we use in the normal tables to be able to tell the probability of the interval between X bar and Xi. So that is what I want us to do. So let me wait for Janet to finish drawing so that we can get to the past papers. So get your past papers ready. Okay, good. So in our past papers, I want us to go to the paper of August 2022 and go to question number 6. Here up this one. August 2022, question number 6A. Question number 6A. No, sorry, B. But B. So the question says that the weights of 1,000 items are normally distributed with a mean of 200 kilograms and a standard deviation of 22 kilograms. Now determine the number of items that have weights between 210 and 220 kilograms. So we are going to have it something like this. Between 210 kilograms and 220 kilograms. So draw a small table like this. Just a small one. Then here at the center is where we have the mean X bar. And this is how you write. The mean we have been told is what? Is 200. And the standard deviation we have been told is what? It's 22, good. So draw up that point. We are up to that point. Now, if we are up to that point, now look at what we have here. This one is a number line, this one that we called earlier, that in our diagram we call X. Number line, that means ukiwa hapa ni 200. So ukisonga juu, it will be 201. Ukisonga chini, it will be 199. So umeelewa hivyo? So if that is the case, where is 210? Kiambia utafuta 210, utaipata wapi? 220 utaipata wapi? Still on the higher side, eh? So you just create a calculator here like this, and you tell us this is X1, which is 210. This is X2, which is 220. And when you are dividing, don't pay attention to the mathematical difference, the numerical difference between this and this, this and this. There's nothing to do with the space. Eh? Yeah. Actually, ukizoea si lazima uchore. So we're just demarcating that way for purposes of bringing it in a clear way. So do that. Then the area of interest is shaded. This one. You shade like this. That is the area that you want. Then from there, you come down here and tell us Z1 is equal to X1 minus X bar, you divide by standard deviation. So our X1 is 210, our X bar is 200, you divide by standard deviation of 22. So do that and give me the answer to 2 decimals. The values of Z are always stated to 2 decimals. .45. 0.45. And it's positive, eh? Yeah, as long as the values of X are on the higher side of X bar, you will always get positive. But when they are on the lower side, you get negatives. Now, Z2 is X2 minus X bar. You divide by standard deviation. So this will be 220 minus 200. You divide by 22. .90. Then from there you tell us from the tables. From the tables. Probability that we are between 210. That is the value of X. And 220. It is going to be. Now I want you to go to your past papers, huko mwisho, and look for a table that is titled normal curve. The curve is, or the table in huko mwisho at the back. At the back, there are several tables. So look for the one that is titled normal curve. Those who are online, once you have seen it, type yes, so that I know we are on the same page. Normal curve. Those who are online, I'm waiting for your response. Good. Now, if you look at that table, it looks like this. It looks like this. And on this side, I think they have written Z somewhere here. Can you see it? The first value here is what? read as it is written, 0.0, followed by 0.1. They continue that way all the way to 3.9. On this side, for the columns, we have values. The first one is what? 0, followed by who? 1. They continue that way all to 9. Good. Then inside here, we have values that are how many decimals? 4. Now, these are the meanings. These values that are in the headings of the rows, these ones, they are values of Z to 1 decimal. Values of Z to 1 decimal. These ones that are in the titles of the columns, they are the second decimal value for Z. The second decimal. The second decimal. These ones that are inside here, they are the probabilities. These are probabilities of the interval between your xi and x bar. I'm saying xi because you can have x1, x2, whatever number of x's. Yeah. So the probability of the interval between your x bar and your x, you're easy. Now, if you have gotten a value of Z, which is 0.26, how you read that? You go to 0.2, that is the first decimal. So, and then you go to line number 6. Where they meet, you read. So do that and tell me the value. 0.26. Nisomee the value. 0.1026. Good. Those are online, make sure you also write in your values. Good. If I tell you, you read for me 3.14. 3.14. You will go to where we have 3.1 and column number 4. Read for me what is there. 992. Good. See, now with that, you can read the value. Yeah. Read for me 7.28. What is the value? I have said read, don't compute. I have said read. What is the value? Janet? Good, hakuna. Now, if you compute a value and you find that it is greater than the table that you have, by the way, it is not every table that goes to 3.9. There are other tables that will stop at 3.0 or 3 point something else. But the concepts of reading are the same. So I'm saying, if you get a value that is more than what you are, or if you get a value that is more than the table that you have, we go by the highest value in the table at hand. So the highest value in this table is what? 3.99. So what is there? Is 0.5. So similarly, if I was tell you to read for me 13.49, it will be, yeah, good. It will also be 0.5. As the next point, that if you get a value that is greater than your table, you go for the highest value. The next point that I want you to notice is this. If you get a value that is negative, Remember I told you, look here. As long as your x's are on the higher side of the x bar, you will always get positives. You see, like now, hii ni kubwa kuliko hii, the same case here, and consequently, the answers here were what? Positive. So, but if your x's are on the lower side of the x bar, then you will get values of z which are negative. You get values of z which are negative. Now, if you come now to look at this table, can you see any negative value? No. So if you can get negatives and the table does not have negatives, how do we go about it? If you can get negatives and the table does not have negatives, how do we go about it? Now, how we go about it is you simply read that negative value as if it was positive. You simply read that negative value as if it was what? Positive. Good. So if I now tell you to read for me negative 2.07. Madam Karibu. Your name is? Nancy. Oh, Nancy. Oh. Nisome 2.07. 0.4808. See, hiyo iko sawa sasa. Yeah. No, you don't put it and you don't put a negative. As in when you're writing your 0. What? 4808. You don't put a negative. Remember, I have said these are all. Nimesema hizi ni nini? Probabilities. Good. And probability can never be negative. Tulisoma tukasema the lowest value of probability can go is 0 and the highest can go is 1. So it cannot be negative. However, the issue of negativity will come in if you want to go backwards. But for now, sitaki kuongea mambo ya backwards. Kwanza nataka tufanye maswali ya forward. Hapo tumefikisha ni forward. So we are left with one thing of going backward. But hiyo nitaongea when we come to a question. Si tuko sawa? Let me recap that the normal curve, these values here are values of z to 1 decimal. These ones are values of z to the second decimal place. These values that are inside here, they are the probabilities of the interval between your xi and x bar. I've demonstrated to you and you have responded well on how to read the values. The other thing that I've said is that if you are to get a value that is greater than the table that you have, you go with the highest value in that table. The other thing that I've said last is that if you get a negative value here, you just read as if it is positive. You just read as if it is positive, but you don't write the negative here. Yeah, so I think that is good enough. So if that is good enough, now let's go back to our notes because tulikuwa tumesema from the tables. From the tables. Now, look here. When you read this one, 0.45, it will give you the probability from 200 to 210. So, as the interval. Now, is that what you want? No. When you read this one, 0.9, it will give you the probability from 200 to 220. Is that what you want? No. So how do we get what we want? It is the whole of this. See what utapata? We subtract this one. Ndio tuachiwe what we want. Umeelewa hiyo? So now we are then going to start with this one. This 0.9. So go to the table unisomee 0.90. 0.90, you are getting 3159. Now this 0.3159, it is the probability kutoka hapa kwa 200 mpaka 220. Sasa nataka unisomee hii ya 0.45. 0.45. Eh? 36. Good. Now, this one is the probability from 200 to 2. So when you subtract them, you will get the probability at 10 further to 20. So subtract them and give me the answer. So that is the probability. And if you want to express it as a percent, some people would want to express it as a percent. This one will be 14.23%. You just multiply the answer by 100. See, how about what's up? So if we are okay with that, the question now does start. How many items are having a weight? So the number of items. So the number of items will be equal to, now this probability that we have gotten here is always expressed as per 1 or 100. So for 1, it is 0.1423. That's one item. And how many items are in this case? 1,000. So you multiply by 1,000. So when you multiply by 1,000, you get what? 142.3. Yeah. See how it was up. Okay. The next question is asking, determine the number of items that have weights between 180 kilos and 230 kilos. Between 180 kilos and 230 kilos. So as usual, we draw like a small table. This is 200. Standard deviation is 22. So 180 unaona kama iko sawa gani? Good. So you come here and tell us this is 180. X1, we have 180. X2, we have 230. So our area of interest is this one. That's our area of interest. We're through, eh? Okay, so we are through with the drawing. As usual, let's compute the value of Z1. So Z1 will be X1 minus X bar. You divide by standard deviation. So this is 180 minus 200. You divide by 22. Negative 0.9. Then we go to Z2. That is X2 minus X bar. We divide by standard deviation. So this will be 230 minus 200. You divide by 22. $1.36. 1.36. So from the tables, probability that we are between 180 and 230. So sasa when we shall go to reach 0.9, it will give us the probability from 182. Is that the entire region that we want? No. When we shall reach 1.36, it will give us the probability from 230 to 200. Is that everything you want? So how do we get whatever we want? We add the two of them. Sasa nisomee 0.9. Naleta ngapi? 0.3159 plus nisomee 1.36. 4131. So when you add 7290. Eh? So if you want to express it as a percent, this is 72.9%. 72.9%. So the number of items is 0.7290 multiplied by 1,000, and that will be 729. Let's go to the next. The next question says, calculate the weight below which 20% of the items fall. 20% of the items fall. So weight below which 20% of items fall. So now this is what I earlier on called the reverse. If you look at what we have done in the others, tulikuwa tunafika hapa tunasema percent, ndio? Then hiyo probability ndio tunakuja hapa tuna multiply nayo 1,000, ndio tunajua how many items. So when they tell us the weight below which the 20% fall, in other words, they are telling us this is 0.2, and that now when you multiply by 1,000, you will talk of what? 200 items. Now, how did we get the 0.729? By your book. The 0.29, we got it after adding two values. So, where did we get those two values from? From the tables, specifically inside the tables. See there? How did we get those values? Or what made us to get to the inside of the tables? The values of Z. I hope you're still following. The values of Z. How did we get the values of Z? We had three values. See there? Kuna formula ilikuwa na three values. Ilikuwa na nani? X1, X bar, and what? Standard deviation. So those values were present. Tukapata value of Z, hiyo Z tukaenda nayo kwa table, ikatusaidia kupata hizo. So when you are now given 20%, unataka urudi nyuma. Na kwa hiyo value ya Z, tumesema there are three items that were present. Tulikuwa na X bar, alafu kuna Xn, then kuna what? Standard deviation. So those are three items. So the one that is missing is the X1. So that is the one that we are going to look for. So when you have it in mind that way, then you just proceed as usual. Kuje hapa. We draw our table. The standard deviation is known, is 22, and the X bar is 200. Very upper. When you are told 20% fall, below which they fall, is that 20% the higher side or the lower side? Kiingereza. Hiyo si QA.
The lower side.
Which side? The lower side. Those are the most right. So we are saying this is where we have the 20 what? Percent. Zile ziko na uzito kidogo. And what the question is asking us is this X1. Now he you have to do it. So what's that? You have to do it. But we have been told that the whole of this is 0. What? 2, the 20%. I have been telling you that when you go to the tables, what you read is the probability from who to who. Is the probability from X and X bar. You can be saying X and X bar. So if for us, if we have to get the value of Z, we must then know this probability is what. But for us to know this probability, if you follow what we did here, tulikuja hapa tukacompute. Tukapata value of Z, tukaenda kwa table. Saa hii hiyo formula ya Z haitaja because hatuna X what? 1. So which way out? The way out is very simple. I told you from the general diagram that we drew, kutoka hapa katikati mpaka mwisho ni 0. What? Look at the diagram you drew, the very first one. 0.5. Na kutoka hapa katikati mpaka huku mwisho tena ni 0.5. Now the simple question is, if you know kutoka hapa mpaka huko mwisho ni 0.5, na unajua hapa mpaka mwisho ni 0.2, can you be able to tell me this is what? It is what? 0.3. So this will be 0.5 minus 0.2, which is 0. What? 3. Fanya hivyo. Get through? So if we are through, tutakuja hapa tuseme hivi. Z1 should be given as X1 minus X bar. We divide by what? Standard deviation. Hiyo ndio formula tumekuwa tukitumia. So hii formula, first of all, these are how many equations? How many equations are these? Kazi ya macho. Hizi ni equations gapi? This is one equation. Equation is two statements that are connected by the equal. That's what we call an equation. So how many are these? One. Good. And for you to solve one equation, you must have just one value unknown. If you have two values unknown, you must have two equations. Here my example here from 1. So hii tumesema ni 1. How many elements does it have? Or how many values does it have? Even nimeandika iko na how many items? 4. Kuna Z1, kuna subdivision, kuna X1, kuna X bar. How many do we know as at now? Is it known? Is it known? Is it known? Is it known? No. So if we have two that are known, then that equation cannot be solved. We can only solve it when we just remain with one that is unknown. But from our rich knowledge about these probabilities, where we know this one, we know very well that this 0.3 ilitolewa kwa tables. Sawa, huko ndani. Na tulipata huko ndani wakati tulikuwa na value of z. So what we are going to do, utaingia huko ndani ya tables. Unitafutie 0.3. Just a minute, eh? Just a minute. You see, when we are drawing this curve, we don't make it that exact. It's called as asymptotic. Why we do not make it is to show that there is an error element. And that error element will make you, when you go to the tables, you may not always get exactly 0.3. There are times you get exactly what you're looking for. There are times you may not get exactly. So in the event you do not get exactly what you're looking for, what you do, you take the value that is nearest to the one that you're looking for. Either slightly above it or slightly below. So with that now, I want you to get inside those tables. You track 0.3 or you locate it. Inside the tables, 0.3. If you are not getting it exactly, you pick the value that is closest to it. Have you seen it? Now, if you have seen it, so angalia hapa. Tutakuja hapa tuseme from the tables. From the tables, Z1, look here. I have told you two things. If you are on the upper side, the value of Z will be what? Positive. If you are on the lower side, the value of Z will be? Let me repeat. If you are on the upper side of X bar, the value of Z will be? If you are on the lower side of X bar, the value of Z will be negative. So in our case here, are we on the lower side or on the upper side? So you expect the value of Z to be positive or negative? Yeah. Itaingia hapo ikiwa negative. Sasa kama umeona hiyo 0.3, nisomee what is in the row. Rudi hapo nyuma usome what is in the row. The title of the row. .8. That is the title of the row, eh? And then that value is in which column? Which column? Si sasa unaangalia hapo juu. 5 or 4, eh? Because it's not exact, eh? Okay, then let's go with 5. But you can still go with 4. No how. Tumeelewa? So kama tumeelewa na si kuelewa, tumeelewa. Now tutakuja hapa. Tuseme now we know this is minus 0.8 what? 5. X1 ndio hatujui, but X bar tunajua ni what? Na standard deviation tunajua ni. Are you able now to tell me the value of X1? So copy and tell me the value of X1 is what? So now tell me X1 is what? 181.3 kilograms. Any question there? Let us go to the paper of April 2022, question 4B. So if you are there, the question says that the savings accounts in a certain microfinance bank have an average balance of 240,000 and a standard deviation of 60,000. The accounts balances are assumed to be normally distributed. So get the proportion of savings accounts whose balances are above 275. So as usual, balances above 275,000. So here we have X bar. X bar is 240,000. Standard deviation is 60,000. So if they ask for what is above 275, then 275 should be somewhere here. X1 is 275,000. We're looking for the ones that are above 275. So as usual, we have Z1 is X1 minus X bar. You divide by standard deviation. This is 275,000 minus 240,000. You divide by 60,000. Two decimals, 0.58. So from the tables, probability that X is greater than or equal to 275,000. Now, look here. When you read this one, it will give you the probability from where to where. From X bar to X1. Is that what you want? No. How do we get what we want? It is just like what I said in the other one. We know from here mpaka wherever mwisho ni. So it will be then 0.5. Tutoe hii. Si hivyo tutasoma na hii. Yes, ndio tuachiwe hii. Because hii itatusaidia kutoka hapa mpaka hapa. But that's not what we want. Tunataka hii hii. But tunajua kutoka hapa mpaka huko mwisho ni 0.5. So you must take 0.5, utoe hii na ubaki na hii. So sasa enda kwa table unisomee. $0.219. 190, okay. $0.281. So when they ask for the proportion that X is greater than or equal to 275,000, proportion is just like the percentages. So it is 0.281 multiplied by 100. So that tells you it is 28.1%. 28.1%. The proportion of accounts whose balances lie between 190 and 260. And 260. So if this is our X bar here, that is 240,000. So 190 should be somewhere here. X1. X2 is 260. So this is our area of interest. That is our area of interest. So let's get our Z1. It is X1 minus X bar. You divide by standard deviation. So this is 190,000 minus 240,000. You divide by the standard deviation. The standard deviation is supposed to be here, 60,000. Negative 0.83. I have said 2 is X2 minus X bar. You divide by standard deviation. So this is 260 minus 240,000. You divide by 60,000. 0.33. So from the tables, we always write the words from the tables because there is another formula that is supposed to be used, but it's a bit difficult. That's why we avoid it, use the tables. So probability that we are between 190,000 and 260,000. See this one now, how are we going to do it? to add. Good. So nisomea ile ya 0.83. $0.2967 plus $0.1293. So when you add them, $0.426. So the proportion that we are between 190,000 and 260,000 will then be 42.6% when we multiply by 100. 42.6%. So let's go to the question of May 2021. Question 1C. Question 1C. So we are told the registrar of Higher Friars University has observed that the grade point aggregate of the university students is normally distributed with a mean of 2.75 and a standard deviation of 0.4. So get the probability that a randomly selected student from the university has a mean grade point of between 2 and 3. So that one I want you to do on your own. Fuate tu hiyo utaratibu tumekuwa nayo, then you give me the answer. Between 2 and 3. What is the answer? The first one. Values of Z should be stated to two decimals. So those who are online, write me the answer. What did you get as the value Z1? Negative 1.8. It should be 88. The values of Z are given to two decimals. But if you work with 7, still okay. Don't change. But next time give to two decimals. The value of Z2, what did you get? 0.63. So 0.63. So did you read these values? There they are. So if you read the values, then the probability that we are between 2 and 3. What did you get? 0.7? 0.56 or thereabout, or thereabout. Let's go to the next one. Those who are online, have you agreed with those values? Roman 2. The lowest grade. The lowest grade is 3 points. 3.26. That is the answer for Roman 2. Roman 3. Those who are online, have you agreed with this one? What's the answer? Mm-hmm. 0 points. Hiyo la Roman 3 si hata ni rahisi sana. You get the probability of 3.7 wale wako juu. Sindio? You get 0.5 minus what you read from the table, then you multiply by 10,000. That's all. Victor, what is the answer? Tumesema you are supposed to say Z1. First of all, tell me Z1 umepata? 2.38. Haya, sasa I'm saying the probability utasema ni 0.5 minus, si tunaambiwa 3.7 and above. Yeah. So hii itakusaidia kusoma from the mean to 3.7, but you want above. So minus what you have read, unasoma nini? Yes, yes, that's what I'm waiting for. Yeah. So sasa hiyo ndio inakupea, hii ni probability kutoka 2.5, 2.75 mpaka 3.7. Sasa tunataka above 3.7. So the difference will be 0.087. So when they ask you the number of students is going to be 0.0087 multiplied by 10,000. That gives us 87 students. Yeah. So on your own, I would like you to do the following. December 2017, question 2C. December 2017, question 2C. May 2017, question 2B. No, May 2016, question 2B. And May 2014, question 2B. May 2014, question 2B. So you will do that. That will be good. I can see our time is over. But our next discussion is called sampling theory. Sampling theory. And in this sampling theory, we have two main areas. One is called confidence interval. And the second one is called hypothesis testing. Hypothesis testing. So if you look at your course outline, you will not see the name sampling theory. You will also not see the name confidence interval. They only have talked about hypothesis testing. But for you to do hypothesis testing, you must have some knowledge about sampling. You must have some knowledge about confidence intervals. So that's why I put them that way. So that first of all, we will look at what is sampling, then we see how do you get confidence intervals, and then that thing will be hypothesis testing. Yeah. So basically, hypothesis testing or sampling theory, it is about how you can be able to observe a small group of items and make conclusions about the bigger group. A very good case in point is what we were witnessing the other day with the pollsters. These guys were giving us the opinion polls. So remember, now what those guys were doing, they were just interviewing very few guys. I don't know whether any one of us here have the chance of being caught by those opinion pollsters. Kuna mtu alipigiwa simu akauliza utapiga kura na nani? But we are all voters. Yeah. So what they were doing, they were just collecting, talking to a few guys, less than 2,000. Some of them could even talk to less than 500. And when they get the views of the 500 Kenyan voters, they now tell us the whole 22 or 21 million voters watapiga kura namna hii. Watapiga kura namna hii. So that is what we call sampling and estimation. You just get a small group of items, you study that group, then from what you see, you make conclusions. Or just like the way you can look at me, or I look at you. And unisome hivyo useme huyu mtu lazima ametoka hii region, kwao kuko namna hii, anakaa kwa hii estate, those kind of things. When you look at a person, can you be able to tell some things about them? Like ukiniangalia venye unaniangalia, are you able to estimate huyu mtu lazima ni wa mahali fulani, lazima ameoa ama hajaoa, lazima kwao wako na pesa ama hawana pesa, lazima akae anakaa Githurai ama anakaa Luga. Are you able to guess? Lazima akuwe ako na gari ama hana gari. Those kind of things. They are what we call sampling. But now, once you have guessed that way, there comes a time when you need to do what? To confirm. It's the same thing that happens with relationships. We are all at an age where maybe at one point or the other, you have been in a relationship or you have been having some interest in someone. When you look at that person, kuna venye kichwa yako inakuambia huyu anakaa hivi, anakaa hivi, anakaa hivi, anakaa hivi, and then you move near that person. But before you do so many things, there comes a time when you need to confirm. Huyu mtu ako namna hii kweli? Huyu mtu ako namna hii? Huyu mtu ako namna hii? Now you go confirming. And when you go confirming that hii nilifikiria ako na pesa ni kweli ako nayo. Nilifikiria anakaa Runda kweli anakaa Runda. Nilifikiria anakaa Kawangware kweli ni mtu wa Kawangware. Nilifikiria ametoka Senti kweli wa Senti. Nilifikiria hii na hii na hii. You go confirming. Once you confirm all those things, now you say yes or you say no. That is the process that you want to go through. So inaanzanga from sampling, then you create an interval, an age. Unasikia watu wakisema mimi nimempea macho na naangalia tu. You are not committing yourself, neither are you saying no. Uko tu hapo. You are giving an interval. Then you start now to test. And then finally you make the conclusion. It's still here in the hypothesis that you shall make what? The conclusion. So basically, that is what we're going to do from our next lesson. And to help us also in the interest of time, I suggest that I set to you notes so that when I come, I'll just discuss kidogo as we go to the questions. Is that okay? And please ensure you copy the notes. Please ensure you copy the notes. That's the best way. It's only that now we don't have a lot of time, and I don't want to keep on calling you here on Sundays. So take that responsibility, copy those notes. I normally see some students when I give them, when I say, notes, please copy so that now as we discuss, it will be okay. So I'm going to send the notes right away in the WhatsApp group. Once you get them, you copy, then we shall discuss them from our next lesson. Thank you so much.